Solutions for the naming quiz. Okay, so let's start with the first ones here. Okay, so I can already tell you that these compounds here are ionic, right? So I'm going to go ahead and label these as ionic compounds. How do I know that they're ionic compounds? Because I can see that there's a metal and a non-metal. So for example, here's your metal, iron, here's your oxygen, okay? Now, in order for this to be complete, because this is the transition metal, right? And transition metals have more than one oxidation state, then we need to make sure that we include the Roman numerals, okay? So for this one, this would be called iron 2 oxide. If you don't know where I got the 2 or why it has a 2, watch my videos on naming with transition metals or naming an ionic compounds. I address that. Okay, this one would be sodium chloride. There's no transition metal, so I don't need any Roman numerals. This is copper 2 bromide. Remember that you have to add the IDE ending in ionic compounds. This is calcium sulfide. This is silver 1 chloride. Whoops. Silver 1 chloride. Even though on your chart it only has one charge, you want to make sure to get in the habit of putting Roman numerals for all transition metals. And this is cobalt 3 iodide. Now, if you did not include the Roman numerals, then it's incorrect because there's multiple charges and you have to include those. Again, I'm still working with ionic compounds, right? How do I know? Because I have a metal and a non-metal. Okay, so this one is not a transition metal, so this is just aluminum oxide. Okay, this is again silver 1 chloride. Okay, and this one is ammonium nitrate. Now, ammonium is not a metal, but it is one of your polyatomic ions. Nitrate, and it is bonding ionically, so you still name it the same way. When you start dealing with polyatomic ions, you just use the name that's already there, okay? Whatever the common name is for nitrate and for ammonium, you just regurgitate it right there on the page. So again, these are also ionic compounds, all right? And because they're ionic compounds, I'm using the rules to name ionic compounds. Okay, here's where it gets a little bit trickier. This is nickel 3 carbonate. So nickel carries a 3 plus, carbonate is CO3, 2 minus. You swap over the charges and you end up with Ni2CO3 parentheses 3. This is the correct formula for nickel carbonate. Calcium nitrate, calcium is a 2 plus, nitrate is a 1 minus. So to form the compounds, remember you swap over the charges, you do the fish, right? So this becomes CaNO3 parentheses 2, calcium nitrate, and then copper acetate, same thing. I'm going to skip this step, so it's going to be CuCH3COO with a 2 on the outside, calcium acetate. Okay, again, still ionic compounds. Now I'm working with polyatomic ions, so I just use the common names. These are super easy. Okay, when we start getting to covalent compounds, I even told you right here that it's covalent. You should have been looking at the rules for naming covalent compounds. And basically the di and the hexa, those are prefixes that tell you how many of each one you need. Diboron means I need 2 boron. Hexahydride means I need 6 hydrogen. Nitrogen tribromide, that gives me 1 nitrogen, and then bromide, well, bromide is bromine, and that means I need 3 of those, right? Sulfur hexachloride, sulfur, if there's no prefix, you understand that it's 1. Hexa is the prefix for 6, so I need 6 chlorines. And then diphosphorus pentoxide is 2 phosphorus and 5 oxygens, okay? So when you're talking about covalent compounds, these are really easy to name. You just have to look at the prefixes, and then the prefixes tell you how many of each one you need. Now, if you don't have the prefixes, that's because they weren't in your notes. That's your fault. So please make sure that you keep up with your notes. This is continuing with covalent compounds. On this quiz, I even told you that they're covalent compounds. There it is. This is going to be silicon, tetra, fluoride. Okay, this is dinitrogen, trisulfide. You don't have to capitalize these. I'm just capitalizing so you can see where the prefix ends and begins, so you know exactly how many you're supposed to put. This one is hydrogen, monobromide. The only one that gets exempt from the mono prefix is the first one because it's understood. Everything else, you must include the mono prefix, even if there's just one. Okay, and then this one is dibromide. Okay, so here you use prefixes to name compounds. Okay, all right. Acids and bases. Let's take a look here. Well, mostly just acids, to be honest. All right, so a good strategy to use when you're working with these, okay, so I already told you, right? I already told you that this is going to be acids. All right, so that should have been the red flag. Is like, hey, let's take a look at our rules for naming acids. Again, if you don't understand what I'm talking about, go back and watch the video that I made for you guys on naming acids. But the first thing to do that I would do is I would identify these as either binary or oxyacids. And here's the hint. If it has oxygen, it's an oxyacid. So oxyacid, 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 binary because there's no oxygen. Oxyacid, 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 binary. Okay. Each one of those has a rule for naming them, and you have to follow it or else it's wrong. Okay. H2SO2. So this one, again, it would be hyposulfurous acid. Well, Mr. Why hypo? Well, let's look at chlorate. Chlorate is a CO3 molecule, right? It has a -1. If you subtract an oxygen, it becomes, so this is chlorate. The one with more oxygens ends with an ATE, okay? If you take away one oxygen, this becomes chlorite. Okay, if you add another oxygen to chlorate, it becomes perchlorate. If you subtract another oxygen from chlorite, it becomes hypochlorite. These are some of the rules for naming polyatomic ions, right? Specifically ones that deal with oxygen. So based on this, sulfur, sulfate, nitrate, they all have the same thing. Some of those compounds don't exist, but you need to understand that if you're dropping below the 8 or above the 8, you have to add these prefixes now, okay? So chloride or sulfite is is SO4. This is the ATE. SO3 is the ite. That's the sulfite. If you go down below SO3, right, this one would become hyposulfite. And if you go above the SO4, which you don't, this would be sulfate, sorry. Okay, so you just got to be aware of that. Okay, if you don't know the rules for naming oxyacids, again, go back and look at my video for naming acids and bases, and you'll understand where I get the IC. Well, I'll just tell you right now. If it ends with an ATE, you get the IC ending at the acid. If it ends with an ITE, you get the OUS ending. Okay, so let's take a look at this. This is the polyatomic ion there is bromate. So this becomes bromic acid. Nitrate becomes nitric acid. Binary acid uses the hydro prefix. So this becomes hydrochloric acid. Nitrite becomes nitrous acid. Okay, this is iodate, right? So this is the form of iodate with less oxygens. So this one is hypoiodous acid. Okay, this is phosphite. This is the polyatomic ion is phosphite. So this is phosphorus acid. And then binary acid again. So this gets the hydro prefix, hydrofluoric acid. Okay. Let's scroll this up a little bit and then get to the last point. You see, this one shouldn't taken you guys more than like half an hour at most. Chloric acid. Okay, so chloric, I get the ICA ending. So I know that's going to be chlorate, right? So that's going to be H2. Sorry, not H2. Chlorate has a -1 charge. So this is HClO3. Hydrofluoric, it's right here. HF. Hydroterylic acid. Okay, so this one's going to look like this. Beryllium is in the same group as oxygen, right? If you look at the periodic table, it's in the same group. So beryllium has a 2- charge. Hydrogen has a 1+ charge. This guy comes over here. This guy comes over here, and you get this compound. Okay. Hypoiodous acid. Well, I mean, it's here, guys. You know. Permanganate. Okay, so in this case, this is using permanganate. So this is going to be HMNO4 because the polyatomic ion is permanganate. Hydrochloric acid. Hydro tells me that it's a binary acid. There should be no oxygen, so that's HCl. Hyposulfurous acid, that's the one we used at the top there. Okay, and then iodic acid is HiO3. Okay, so here's the solutions. Okay, make sure you include these into your notes, submit the file, and then I'll bump your grade a letter grade. Okay, this quiz should not have taken you guys as long as it did, especially if it's open notes. If you're still having trouble with these, that means you really didn't pay attention to the videos that I made you, and you haven't been asking me questions. So please make sure that you guys are staying on top of this because we're going to be using these compounds for the rest of the year. Okay. This shouldn't take you more than 15 minutes. Get it done and enjoy your break.